The concept of pointers and arrays in C or C++ go together. There is a very strong relationship between these two concepts, and in this lesson we will be discussing this relationship. When we declare an array, let's say we declare an integer array a of size 5, then we create 5 integer variables named a0, a1, a2, a3 and a4. Now these 5 integers will be stored in the memory as a block of 5 consecutive integers, something like this, what we are showing here in the right. If a0 or the first element in the array is stored at address, let's say address 200, and in a typical compiler, modern day compiler, integer is stored in 4 bytes, so a1 will be 4 bytes ahead of a0 at 204, and a2 will be at 208, a3 will be at 212, a4 will be at 216. The overall size of the array would be 20 bytes, and these 20 bytes will be one consecutive block. We are only showing the section of the memory in which A is stored. Sometimes we also show the memory horizontally, something like this. From left to right we increase the address, but these two representations are just for the sake of understanding. Let's use the horizontal representation of the memory this time. I'll show this memory a little more extending towards the right so that I can accommodate a couple of more variables. Let's say apart from this integer array A, I have an integer variable x and its value is 5, and let's say x is located at address 300. Now let's say I have a pointer to integer p, and in p I store the address of x. If we print p, then the value in p would be 300, so this statement will print 300. And if we dereference p and try to print the address stored in, try to print the value stored in this location p, then the value would be 5. This is fine, but we also know that we can do an operation something like increment or decrement a pointer variable by a constant. So we can do something like p equal p plus 1, and this will take us to the address of the next integer, and because integer is 4 bytes, so now p would be 304. So if I want to print p now, then the output should be 304, but if we try to dereference p now and try to print asterisk p, then we do not know the value at this address, so we cannot say what will be printed. It's like we know that Mr. X lives at address 300, but we do not know who is his neighbor who lives at address 304. But for this integer array A, let us say I'm writing the same integer array in the right here, which is located at address 200. If I declare a pointer to integer p and store the address of the first element by putting an ampersand operator in front of a0, then printing p would give us, in this scenario, the output 200, and printing asterisk p would give us. But before that, let's say we have these values in the array. Let's fill up some values in the array. So asterisk p would be 2. Now if I want to print p plus 1, then the address would be 204, and if I dereference p plus 1 and try to print this value, then it will be 4. And similarly, if we wanted the third element in the array, we could do a p plus 2 here. So using pointer arithmetic makes sense in the case of pointers, because in the case of arrays, because we know what is in the adjacent location. There is one more property of the array. If we just use the name of the array a, then a gives us the pointer to the first element in the array. So we can write a statement like p is equal to a. In fact, we do not even need to take this address in another pointer variable. If we simply print a, then this gives us nothing but the address of the first element in the array. And if we want to dereference this and try to print asterisk a, then this will give us the value. So if we want to perform something like we want to print a plus 1, then this will give us the address 204, and asterisk a plus 1 will give us the address of the second element in the array, value of the second element in the array. For an element in the array at index I, we can retrieve the address of this particular element in the memory using either ampersand AI or simply a plus I, and these two will give us the address of AI, and the value of AI can be retrieved using either we simply use AI or we can also use asterisk a plus I, and asterisk a plus I will also give us the value. Now this is an important concept. We can write ampersand AI or a plus I for each other and they mean the same, and we can write AI or asterisk a plus I for each other and they mean the same. The address of the first element in the array can also be called the base address, and a, simply using the variable name a, gives us the base address of the array. Let us now see some code examples and try to solidify our concepts further. In my program, let's say we have an integer array a. Now as we said, if we simply print a, then this should give us the address of the first element in the array, and we can also get the address of the first element in the array by using ampersand operator in front of a0. If I simply print a0, it will print the first element in the array, and we can also print the first element in the array by using asterisk operator in front of the variable name a. Let us now run this and see what happens. And I also need to put an end line after each of these print statements. Okay, so the output is that the first two lines are the same. They are giving us the address of the first element in the array, and the second two lines are giving us the value. In fact, if we run a loop like this from 0 to index 4, then we can print address of the element at index I as ampersand AI or a plus I, and we can print the value of ith element as AI and asterisk a plus I. Now if we see the output here, this is a fresh run, a new run, so the address allocations will change. But if we see the address printed in two lines, for a0 is same, the value is same. Again for a1, the address is same, 4 bytes ahead of the previous address, and the value is as expected, and we can go on like this. Now one more thing, even though just using the variable name a returns us pointer to the base address or the address of the first element, and we can equate the variable name a against some pointer variable like this, we cannot do something like a plus plus, increment the value of a. This will give us compilation error. We can do something like p plus plus once we assign a to some pointer variable, other pointer variable, but incrementing a itself would be invalid. So this was how arrays are stored in memory and how the addresses can be manipulated and how we can access the values using pointers. In the next lessons, in the coming lessons, we will talk about character arrays and we will talk about passing arrays as function arguments. So thanks for watching.